Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled A Year of Sunspots. So, what do we see here? Well, in what might look like a flower, but is actually multiple images of our sun. And the central one puts together all of the sunspots of last year. And 2025 was likely the peak of the last solar cycle. So we should be having fewer and fewer sunspots, although it's expected that this year we'll still have quite a few before it starts to drop off over the coming years. Now, the sunspots are actually darker areas on the surface of the sun, meaning they're slightly cooler. And they're not cold by any sense. The surface of the sun is about 6,000 degrees on average. A sunspot might be 4,500 degrees, so it's definitely cooler. It's still incredibly hot, but it looks dark against the brighter background of the hotter solar surface. Could you somehow take that material in a sunspot and put it out in space and look at it? You would see it glowing a deep orange color because it is still that hot. Now, the surrounding images just break this down by month. So one image for each month of the year and seeing how the sunspots were present and then putting them all together in a central image. And a couple things we notice, first of all, is that the sunspots are confined to the central region of the sun. We don't find sunspots close to either of the poles. They're always pretty close to the center, and you see just rare ones that stick out a little bit farther away. And that likely has to do with the sun's magnetic field and how the sunspots form. The sunspots are regions where there is less energy being produced, less energy coming out from the surface of the sun, and that tends to happen where the magnetic field is strongest. So where magnetic field lines break through the sun in the sun's magnetic field, that's going to cool it off. It's going to inhibit the energy transport from the center and cool off those regions. Now, why does this happen? Well, the sun doesn't rotate like a solid body. The equatorial regions actually rotate faster than the poles by several days. And that means that every month or so we lap, that the central regions will lap the poles. And that twists up the sun's magnetic field, eventually tangling it so much that bits of it burst out through the regions and will then be able to inhibit that energy transfer and give us the sunspots that we see. Now, sunspots, while they're the easily visible sign of solar activity, they're very easy to see. But there are other signs of solar activity, things like solar flares and coronal mass ejections, which can have a much larger impact on Earth. The sunspots themselves don't really do anything, but a solar flare being ejected from a region around one of these sunspots, that can actually have effects here on Earth, including giving us the aurora that we sometimes see in our images here, as well as affecting communications on Earth by causing excess interference with things like communication satellites. So a very large solar storm could cause significant problems like that. So here we get to see the entire year of the sunspots of the peak of our sunspot cycle all put together in a single image. So that was our picture of the day, titled A Year of Sunspots. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.